Great. I'm trying to set also a, if I start talking, probably I will talk a lot. So I put also control over the time. Hi, good evening. My name is Sahar, and thanks for the introduction, Robert. Well, actually, I'm here for 3 reasons. One is, the interest in the meetups, and how I'm related to these conversations is that I work on natural language processing, and you will hear this quite a lot today. And I'm also organizer of the Stockholm NLP Meetup. So in case you find this talk interesting, you probably would like to join the meetup. And so before we start, I would like to know who in the audience are familiar with NLP in any sense. Okay, not bad. So this is about understanding social conversation. And when I started preparing the slides, I had a hard time to figure out the balance of the technicality. So sometimes it's like a very high level, sometimes it's more detailed. And feel free to interrupt me and ask your questions whenever you have one. All right. So what am I going to talk about? First, I will explain a little bit about us in Meltwater, what we do, a little bit motivation behind the understanding social conversation, and actually what is NLP, and specifically in NLP, I will talk about name entity recognition, what it is, why it's important, and how we address name entity recognition. And then I also talk about moving for name entity recognition from editorial topics to social topics and different languages. And then we will have further discussions and a demo. So a little bit about Meltwater. Where is Meltwater? It's a business intelligence company, and we work on providing insights from data outside firewall. And by data outside firewall, I mean like news, blogs, social media, and this kind of data. And basically, we try to provide insights from those. And Meltwater is originally a Scandinavian company. It was founded in 2001 in Oslo, and currently the headquarters is in San Francisco. It started as a sales-driven company, but the past few years it had an aggressive work on having more developers, engineers involved, and a lot of researchers in the field of NLP. So we have more than, at the moment, 1,000 employees around the world. And as you can see, we are quite scattered around the world. And we have 23K corporate clients, 50 offices across all the continents. And we have more than 120 employees, I don't know exact number, in engineering department. But more specifically, I'm coming from the data enrichment team in our company. We are around 24 employees, and we are located in Stockholm, Budapest, Bangalore, and San Francisco, and work together. And what we do is basically starting from proof of concepts and making a prototype and productizing a new idea or a new feature to have a better enrichments from documents and to be able to extract better insights from those documents. And we also have an in-house framework, a kind of a lab, that we experiment with our new features, and we collect product owners' feedback on those features and users' experience and make it happen to get to the product. Okay, so a little bit of acknowledgement. Well, the topic that I am talking about it today is has been probably 1 year long mission in the company, and a lot of that has happened with my colleagues in data enrichment team, and especially Bhaskar Chakraborty. Can you raise your hand? Yes. So I will represent them here. Okay. but what is the vision that we have in the company? The whole idea behind this extracting insight is that, like, when you get to the office, you have your morning coffee. Meanwhile, you want to get to look for what you are looking and searching. You want to get some insights to be able to make informed decisions already while you're having your coffee in the morning. So what you're looking, for instance, you want to get more information outside firewall about your own brand, about competitors, about your own industry, and about the leads, partners, product reviews. Examples of such are, like, for instance, Securitas, the security company in Sweden, is using Meltwater to find new instances of vandalism and break-ins. And for instance, Sanofi is using Meltwater to be alerted of when certain patent will expire in target market. And or like Kimberly-Clark is using Meltwater to determine how public perception of certain ingredient chemicals will influence adoption and sales, and so on. So, but how we do it? We've built an application upon that, so that we process all those enrichments, make those enrichments, and then we provide insights to our user. And again, all of this is like about processing text outside firewall. For some technical reasons, I will keep the demo to the end, so to make sure that we don't switch back and forth from the presentation. But we will get back to the demo. Okay, so this was the front end part of it, the face of it, and this is like how actually in the behind the scene happens. So we crawl a lot of contents, and we have a lot of raw documents crawled, and it's unstructured data. And we have an enrichment pipeline. So each document gets to the pipeline, gets a lot of enrichments. And for example, extracting the key phrases, extracting the name entities, finding the sentiment of entities, finding the concept categories of that one single document. And we put all this, we represent each document using all these enrichments, and we index all those huge number of documents in our search system. And then, yeah, through our application, user can request for a search and related widgets and get the results. We currently support around 15 languages in different levels of enrichments. And yeah, as I said, we do sentiment analysis, categorization, key phrase extraction, name entity recognition, and disambiguation, of course, is not limited to only these. But so what? Why do we do all these things? The thing is that, there is so much data accumulated outside the firewall of a company, and there's so much mention about that company or like a client that they want to filter and find out related information and find out all those accumulated outside firewall. And we try to help that. Examples of like how much data we are talking about, like there are per day more than 100K news articles, 340 million tweets, 0.5 petabytes of data from Facebook, and more than 100 hours of new videos are added in YouTube per day. So we use NLP to process documents, extract information, and provide insights. But what is NLP? Well, I mean, we are talking about NLP, and we may want to make sure that we don't ambiguate anything. So I went and searched in the free dictionary for acronyms. And this came up from a conversation with one of my colleagues from back in the university who has a nonlinear programming background. And we both talked about NLP, but he meant nonlinear programming, and I meant natural language processing. So just to be sure, we are talking about natural language processing here. And specifically, I'm talking about the statistical natural language processing, which means that we try to extract information from large number of data and try to predict the behavior of next coming document using those statistics, like statistical models from those documents. Okay, fair enough. But where is NLP used? Well, I mean, typical famous thing that you have heard about probably is IBM Watson for question answering. Then the other thing is the text summarization, and then information extraction. Let's say like you have a bunch of information of like an invoice that this person meets the other person at this location in this time, and you want to extract all those information and relate it to each other. The other thing is sentiment analysis. So when you read an article about like I don't know, like about Google's brand, like Google wants to know if there is a positive opinion around Google in a document or it's a negative opinion around that. Yeah, well, I mean, probably you get a lot of positive ones. But then the next one is machine translation. So like there are a lot of applications of NLP for automatic translation or helping translators with suggesting like a set of suggestions for translation of a word. Then it's paraphrasing. Like one document is talking about something and the other one is also talking about it, but like a similar matching doesn't find these two documents are similar. But if you have a good paraphrasing, you may actually find out the paraphrase of the other one is equal to they are talking about the same thing. The other thing is relation extraction. So let's say like you want to know if we are talking about Obama and White House and I don't know, like Prime Minister of Sweden, then if it's also about White House and Prime Minister of Sweden, is actually about Obama and Prime Minister of Sweden. So you want to get all those relation extracted. The most important things that I really like is the information retrieval, because the base of getting a good information retrieval is that you have proper indexing of documents, you have a well-described queries and how you can relate it to the documents, how you can describe that query to find a good match to the documents. Another example is the language generation. So let's say, like, for instance, you have a lot of sensory information, signals, and you want to map them to human-readable information, and then that's the topic of language generation, example of that. And then we have also topic modeling, because sometimes you might be interested in documents, but not in the syntactical form, but more of about what is the concept or category of that document. And yeah, so this is where it's NLP used, but it's much more. I mean, you find people that they have like biology background and do like health data analysis, medical data cleaning. You find people in juristic that they process a lot of juristic documents and so on. So this list continues. But there are some basic buildable blocks for each NLP application that you have. The very first one is a tokenizer. What is a token? Token is a sequence of characters grouped together as useful semantic units. And I mean, for instance, in English, the main clue is that you look at the white spaces or line breaks, and then you say that's like how we detect tokens. In this example, for instance, Einstein is a token, was born in 1895, and also the point. The next thing is that, well, I mean, the minimum meaningful part of the document that you have is also a sentence. So you want to analyze those tokens within a sentence. And the main clue in English is you look at question mark, exclamation mark, or stop points. But also there are some challenges. I mean, not all periods or points means end of a sentence, or there are also some things like, I don't know, semicolon that also mean that they are like a sentence boundary. And yeah, I mean, sometimes quotes of a speech are within one sentence. They don't indicate one sentence. So simple one you can create, but for more like accurate one, you have to be more careful. The next module is part of the speech tagging, or a kind of a parser, which means that within a sentence, tokens of the sentence, we want to know what is the syntactical role each token has. For instance, here we have, I am reading a book, and the second sentence is, he wants to book that flight. And book in the first one means it's a noun, and in the second sentence is a verb. And knowing the part of a speech tag of each, like this token, can be very meaningful later on to build more complicated NLP components. Okay, is there any solution out there? Yes, of course. I mean, there are a lot of developed components that you can use. OpenNLP, that is a library or in Apache. It has a lot of existing, let's say, tokenizer, existing part of a speech tagging in different languages, which you can use directly and import it to your NLP solution. Gate is a standard framework for annotating that holds annotation of documents, and it contains any package which has a lot of NLP functionalities that you can use. The two that I will suggest you more to look into is Core NLP from Stanford. It's a Java-based implementation. It does also have their own models. You can start already using their tokenizer, part of speech tagging without creating your own, and even build a name entity recognition. And NLTK, it's also an NLP toolkit that is in Java, and it's quite widely used everywhere. And again, similar to Stanford Core NLP, you can use it in Python. Umia is also a framework for NLP, and Clear NLP, honestly, I haven't looked at it yet. I just found it recently, and apparently it's a Google source for a framework for building NLP pipeline. Yeah.
Is there a reason why the two you recommended are built in Java or written in Java?
Can you repeat your question?
Is there a reason for Java being the language that they've used for the ones that you recommend?
I recommend the Stanford and NLTK. Stanford is Java-based, NLTK is Python-based. Okay. So, I mean, you can go for any of the two. I think originally people probably started with Java first, but each of them, they have their own benefits. One of them is faster, probably for text analysis. It has more like machine learning toolkits in Python that you can just plug them to your NLP pipeline and use them. But also, there are a lot of other functionalities around in Java if you want to create a framework that has part of it as NLP as a whole package, which sometimes I would prefer it. So it depends on what you want to use it for. But I think as the starting point, these two are very good because they have existing solutions and they have very good examples and documentations that you can use. And yeah, common programming languages are Python, Java, and some Scala. And yeah, anything that also is related to machine learning can be used in NLP. So, okay, so far so good. So let's build a name entity recognition component, which is a more complex and advanced NLP component. But we should first know what is actually name entity. Well, name entities, if I go for a non-linguistic definition, they are referable entities. They are usually proper nouns, and means that they are referring to an entity that we can refer to, and they can be single or multi-word. For example, I know this man. He might be Charles, and the Charles here is a person, like it's a name entity because we can refer to. But if you say a man, I can't refer to, or I is a pronoun. We can't refer to that. And then in the next sentence, he lives in Stockholm. He's Swedish. So as you see, Charles, Stockholm, and Swedish, they are all of them name entities, but they have different categories. So what actually a name entity recognition component does is that to extract the boundaries of the tokens that are making one name entity. And the second level is to find what is the category of that name entity. So in this case, like, we have categories of, like, yeah.
Quick question.
Yes.
I understand why Charles and Stockholm are named entities, but Swedish, isn't that more description of something?
Well, you have a very good question. The thing is that, you know, we when we created our own name entity recognition, we had to define, we gave to a lot of people to annotate documents for us, read them and mark the name entities. And one of the challenges for us was to build a guideline for them to say what is a name entity. And then there are some standards for editorial text. There are some standard definitions. Like, for instance, from the Connell conference, they have some contests that you can build a solution for like an NLP challenge. And there was like a standard guideline that we based it on. There, some of the adjectives which are describing an entity still, they are also name entities. So Swedish, like nationalities, are also considered as name entities. But you may go to another guideline and they say, no, they are not. They are in the boundaries, I would say. Okay, so yeah, here you see John is a person, and Stockholm is a location, and Ericsson is an organization. And like categories, in the Connell, the categories are person, location, organization, and miscellaneous. But like when it comes to, like, you know, industrial application, for us also makes sense to have, like, for instance, products for branding. And yeah, okay, but what is that does not include in NER? So when we are talking about NER, we don't mean like a simple string matching, but actually is like a classifier that we identify those name entities, and we don't use a purely only a predefined list of names. We might get help from them, but not only using them. And we don't create any template that, okay, this is a standard way of talking about organization, this is a standard way of talking about a person, and make this rule-based name entity recognition. And name entity recognition does not perform co-reference or entity linking for us. So if in a document we have Mr. President Obama and Barack Obama, it doesn't tell us these are the same people. It doesn't make this co-reference for us, but only detecting the name entities that, yes, these are name entities and all of them are person. And it's not an event detection, but it can help us in building an event detection. Okay, but why NER? Well, I mean, I don't go through all this list. I basically want to go to the last two ones as an example where name entity recognition can be very useful. And of course, you know, because many packages of like applications of NLP are built upon name entity recognition, of course, it's very important to have a very high accuracy for name entity recognition. Otherwise, you know, it messes up your results and performance in other applications. So let's go for one example, entity level sentiment. So let's say we have this sentence. It's talking about McDonald's with negative sentiment and talking about Panera Bread, chicken fillet, and Chipotle as positive. So if you read the document, probably you say this is positive or negative, but it's not that important for us only that what is the sentiment for the document, but also what is the sentiment around one specific name entity. It might be that, you know, if it's like talking about two competitors or a review, of course it's like negative about some entity and positive about another one. So we are interested to identify what is the opinion around one specific entity. Like most of the works that you see around is that, well, I mean, it's the document level sentiment that people use, and there you have three annotators. One says this is positive, this is neutral, and this is negative. But of course, it's like about which entity they are looking at the document, and then they start, you know, concluding about the document. So, and yeah, a lot of machine learning approaches is used, but this is not what it makes sense for our industry. We are more interested in having a entity level sentiment. So we use NER, extract the entities, find the relation of them in the document, use a machine learning approach, and then find out what is the sentiment around those entities. This is an example, like you see, like we have a use case of different entities and what is the sentiment around each mention of them, like each document's talking about them. Another example is knowledge base. Like NLP is very, name entity recognition is very important when you want to build a knowledge base. So let's say you have a huge database of entity roles, and then you define their relations and you store them in a knowledge base and how they are related to each other. And it could be based on different things. For instance, if we have a good, we build such a knowledge base, we can build a very good entity disambiguation. You see, like here is documents talking about IBM, Big Blue, and the IBM partnership, but we realize that all these documents are actually talking about International Business Machines Corporation, and it's about the company IBM. And yeah, or like here you see, for example, we have two examples about Gates. One is about Robert Gates, and one is about William Henry Gates. And you like a good, not such a knowledge base can help you to identify the text is talking about which of these two. Okay, so I hope that I motivated you enough that we should learn and use name entity recognition. Now we want to see how to build it. So as I mentioned implicitly, name entity recognition is basically a text classification task, meaning that we have a training, which is like we get a large set of documents and we have annotation for them for each of the name entities, and then we extract some features from those documents and we use a machine learning algorithm and we build a classifier model. And then in the prediction stage, we get a new document that we haven't seen it before, our model hasn't seen it before, and then we extract the similar kind of features and we give it to the classifier. We want to see what the label it predicts. Okay, this means that we want to collect some data. If we want to build an NER, we need to pre-process them, decide on the features, use a machine learning tool, evaluate it, and use it. Pretty straightforward. So more detail in case of name entity recognition. Let's say we have a corpora, a large set of tweets. We tokenize them. We extract the features for each of those tokens. And then we use a classifier, and then we get the NER result. I talked about so far the labels of name entity recognition. I talked about the tokenization. So now we will talk about feature extraction and also the classification. So let's go for the features first. One example and a strong feature is Gazetteers. Gazetteers are basically a list of names for a specific category. You can have, I don't know, like crawl all the names about like names of people in Sweden and build a Gazetteers for Swedish names, or like locations and organizations. Okay, very good, but what is the disadvantage? You should be very careful when, although it's a very strong feature, but you should be very careful because one problem is that it's difficult to create one good quality gazetteer and then also to maintain it. And also, if you go for a commercial one, it would be very expensive. And also the usefulness varies for different categories. For example, a gazetteer of persons probably is easier to create them and gazetteers of location or organization. And then we should also be careful about the ambiguities, meaning that let's say like you have a name of a place that is also name of a person, then you have it in two gazetteers, and then this feature can mislead you. So you have to be careful and handle these things. Another good feature is word clustering. So let's say like we want to talk about the to Shanghai, and we haven't seen it in our training, but we have seen in our training things like to London, to Beijing. So if we know that the role of Shanghai is similar to the role of London or Beijing, then we can realize that the role of to Shanghai is similar to the role of like a to Denver or like to London that has already been in our training data. One example of word clustering is Brown clustering approach. It's a hierarchical approach, and it's basically clusters things based on their contextual similarity. I give you, and it's an unsupervised approach, meaning that you don't need to have a label data. You need to have a huge set of related articles in your domain and just basically put them in a clustering and get the clusters. Example. So it has two assumptions. One is that similar words appear into similar context, and which means that similar words have similar distribution of words to their immediate left and right. So meaning that, like for instance, if you have last or on, it's like all the days of the week, they become to one cluster because they have the same pattern of distribution on their immediate left and right. Okay. And yeah, by the way, the clustering looks like a binary tree, and the leaves are those tokens. So with like the similar clusters, like the similar sub trees that they have like similar contextual context, they have similar matching in their bits on the left side. So they fall into the same subtree. Okay. So these were like external features about tokens, but there are also some internal token features. For example, shape of a feature. Let's say you have like capitalization. Usually in English means that it's talking about like if a name is capitalized, most likely is a name entity. This is not the case in all the languages. I've seen some of the examples of like in Swedish, you don't write everything in capital if it's a name entity. Okay, so let's say about the classification. The state of the art is like mostly about supervised learning, and recently also moving to semi-supervised and unsupervised approaches. The most standard one is conditional random fields, that like if you go to core NLP from Stanford or NLTK, you get the same tool for name entity recognition, and we use the same standard approaches in our name entity recognition as well. But one problem, though, with supervised approaches is that you need to have large set of annotated data, and this can be expensive. If you want to build your own solution, there are like some label data that you can use, but if you want to make it like a domain specific, then you have to have this huge amount of label data. There are some solutions, they have some drawbacks, we can discuss them offline. One solution is that people go for extracting automatic name entity annotation from Wikipedia data. But you should be careful, that's a Wikipedia domain data. And the other thing is latent Dirichlet analysis based on detecting name entities using Gazetteers, which is a semi-supervised approach. But yeah, I don't go to the details, but if you like, we can like at the end discuss about them. Okay. It seems very easy. It seems that there are already a lot of solutions that you can use, but what's the catch? What are the challenges in real applications when you want to listen to the conversations, or what is about like when you want to move to another language from English? I gave all the examples in English, right? And what about if we go to the social domain? I gave all the examples in editorial domain. Okay, so here I go to, you know, giving some speech or lecture of like what not to do and what to be careful about. So I don't know if you have seen this, but it's like you should be very careful in selection of which set of features you combine together and what samples you collect and what model you use. The stories behind this is, I think, like a blind man asked some people to go and sample and find out and describe him an elephant, and this elephant was in a dark room. So each people come with some description, some features, and this is what they got. So you should be very careful how you build your system. The other challenge and the catch is the ambiguity. So here we have 1, 2, 3, 4, 5, 6 sentences all talking about Washington, but they belong into different categories, and all of them are name entities. The first one, Washington was born in 1732. When, as a human reader, when you read it, you quickly say that, oh, it's born, so it's a person. But it's not that easy for a generic solution. Or, yeah, you see organization, location, geopolitical entity, vehicle, and a faculty. Okay? Yeah, this is my favorite one. Also you have to use a very good parser or part of speech tagging too, and look at the syntactical rules as well. Honestly, I have to confess that I can't read it yet, but this is a Wikipedia page of buffalo, 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 buffalo. And, it talks about city of Buffalo. It talks about the verb buffalo as like confuse, and it's also talking about the animal buffalo. Yeah, so we have this kind of ambiguity too. The other challenge is the language dependency. So when we go to Japanese or Chinese, then the words are not separated. So you have to come up with another solution of like tokenization. Or when it comes to part of a speech, in English it's quite easy. Well, you have to be careful about the plurals, but that's all about it. But then you get the inflection in English only for, as I said, for the numbers. But in German you get the inflections for the numbers, gender, and for case. And then this was only about nouns. For verbs, I've worked with Finnish language, and I dealt with I don't have a Finnish background, so at the end I realized that I should have studied first a little bit about Finnish language, because you may end up to have 10,000 forms of verb, and that's difficult to make a generalized approach, and you have to be very careful about the language that you use. And also, I talked about the shape feature. In English, all the proper nouns are capitalized, but in German, So in languages like German and in Swedish, the capitalization means totally different. Also, when it comes to social language, it's even worse because there is no capitalization. Okay, and this is another second most favorite. That basically is talking about inflected and agglomerative languages, and this basically talking about the dog and two dogs. Comes to Swedish, you see it gets more. German gets even more, and then that's what I dealt with for few months to be able to find a good name entity recognition. Okay. So, to sum up, a study of linguistic properties of a language is very important to build a good name entity recognition. Getting to the fun part, which is the social data, and we have tried to use the model that is built based on editorial articles and apply it on Twitter data. Believe me, didn't work. You don't get close to 50% accuracy either. And you see, this I forgot to put the reference. I should. This shows that the more the content is user generated, the more drastic the F-score value or the accuracy drops. But what is it about it that we have to look into first and then build our blocks? One of the things is that, okay, now the policies of Twitter is changing, but most of the accounts are 140 character limit. It talks about a wide range of topics. It's not just like a polished editorial text. It's mainly talking about specific audience, about, I don't know, like economy or finance. but it has a very wide range. You can't just categorize them to person, location, organization, product, and that's it. It's a lot about, I don't know, TV series, let's say. And, well, it does have a broken language, and there is a lot of misspelling. So, meaning that you can't use the same components anymore. Some examples. So, in addition to all these things, we have also things like hashtags, retweet, and mentions. And you should be careful because, like especially mentions and hashtags are meaningful things in a tweet. And then, yeah, you see, like, it is actually, oh my God, this is misspelled, and this is, oh my God, and I mean, we don't have it in editorial place as yeah, okay. So, and you see, yeah, I mean, there is no, it is with a small letter, and there is no space there to detect the sentence or token boundaries. So, what are the solutions when it comes to social data? Well, introducing social features that can handle hashtags and like mentions and so. And then the other thing is adapting our existing features to social properties. So let's say like we have a post tagger. We actually have evaluated it. A post tagger that is editorial, it performs really poor on social data. And so we need to use build a new post tagger, or if we don't have it and we want to use editorial, then we have to have a, you know, a coarse processing, post-processing on the post tags to apply, I don't know, like all the URLs, make them as a URL part of a speech tag, or like hashtag becomes a new part of a speech tag. Then we have the tokenization that we have to improve, but, well, we can deal with that probably. Yeah, I talked about the hashtag and RTs, and then, you know, one of the features that I talked about that is a strong feature is word clustering and word representations. Here we have, well, we have a lot of misspelling, and I mean, we have to create some, like a kind of a brown cluster that adjusts to the social data. It's not that difficult, but we have to take care of it. And considering, you know, these things, you know, the importance of different features from in editorial could be different from social. So you have to do a new study. And word shape, yeah, of course. I mean, you have everything in small letters, and sometimes everything is capitalized. So the second thing that I would advise is, as I said, analyze importance of each of features in your model. See what has the highest impact, what has the lowest impact. And then if you want to improve things, you start looking at those that they have highest impact on detection of name entities, and then improve them into your context. Then, you know, if you want to be selective, then there is a higher chance that they help you in building a better name entity recognition. Okay. At the end, when we build one, we want to also evaluate it. Again, this is from Wikipedia. The typical measures are precision and recall and F score. What precision tells us is like how many selected items are actually relevant, and recall is telling us how many relevant items are selected. Okay, and F score is like a harmonic mean of these two. But okay, seems easy, but still, let's say we have a name entity, United States of America. If your name entity recognition finds like United States as name entity, but not United States of America, how do you penalize it? Because what I described is penalize it fully. What about partial matching? The other question that you should be careful when, like, you read someone's results that they claim that I have a 90% of accuracy, is that how much they penalize if the name entity is recognized, the boundaries are recognized, but the category is wrong. If the category between location and organization is wrong, is it a big difference? Or when it's between a person and a location? How should we consider this in the evaluation of our algorithm? And then the other thing is that, okay, we say precision and recall, but we should see which of them for our customer is important. It gives a better user experience to their need. Do we want to have a higher precision or higher recall? Okay, so we actually followed all these, lessons. I told you lessons learned, that we have actually tried them and suffered from them. So we built our own name entity recognition pipeline, and for the social, we try to use the social features as I explained to you, and we compared it with the state-of-the-art from 2011, and here you see different categories that we have, and then you can see the precision and recall and the comparison of the two. We have, and yeah, this is like the accuracy from 0 to 100%. And you can see, like, the one that is better has the higher coverage of the area in this chart. And this is the blue dot is our precision, and this is the state-of-the-art precision. And this is our recall, the yellow one. And this is the green from the state-of-the-art. So I would say it was a very successful experiment that we did, and we tried the social features to build the NLP component. Okay. Yes.
Did you try using this on, for example, Facebook, or would
No,
that be
we did work only on Twitter data. Because this was, well, there are analysis on microblogs, and many of the social documents are considered as microblogs. But then there is another category of that some people consider Twitter also as a microblog, some doesn't. We purely analyze it on Twitter data. People usually in their analysis, they don't mix them up. We recently are also working and to see and evaluate it, how it works on Facebook data. I don't have any number yet to tell you. Yeah.
But you think it would be a completely different model, right?
I would say it will be much closer, because many of the challenges that I talked about, I would say Facebook is somewhere in between editorial and the social data, because you will have you still have a lot of categories compared to editorial. You have less misspelling because people spend more time of writing their status, and maybe they have a spell correction or something like that. But still, all these, like, not using capitals, the shapes and grammatical rows, or using strange out of dictionary words still exist. That's why I'm saying my guess is somewhere in between. And considering our experience with two different features, I would personally go for, let's see how it works with editorial, how it works with social. Is it good enough? It's not. We build a new model.
Do you deal with ethical questions in any kind of structured way, like should you provide certain data to a customer or something like that?
Can you elaborate a bit?
I don't know, like for a political person, who's liking his politics and what areas they don't like it, or something like that. Like the Sweden Democrats, would you provide them with the data about anything that they could sort of be interested in? Like,
okay, you are asking two questions at the same time. One is, in general, the ethics in Meltwater, that to what customers we provide or not provide. Because at the end, like, the salesperson goes to someone, talks to them. I can't answer what is the red line in selling, but I've asked the same questions from my managers, and I know that there are like specific ethical boundaries. But since I'm more of a researcher, I can't answer that question. But the second question that you are asking is that if a customer wants to have specific criteria for the search, if we can apply it or adjust the search result or not. And the answer is yes. And I will get to it in our demo. I don't know if I managed to answer your question.
Yeah.
Okay. Okay. So, Robert, you put the theme about Star Wars in the meetup. So I came up with this one. That well, the gist of it is that how you use your tool is more important than what you have. So just to wrap up of what I said, you should really look at the application that you want to use it. A friend of mine actually built a name entity recognition component, came to me and said, well, I mean, I've built something that is even more accurate than yours. And how is that possible? And we try to investigate, and we find out that if you build something that is oriented in only one specific domain, then probably you get a way much better result, and it works in that domain, but doesn't, generalize. For instance, if you have a name entity recognition for persons, probably you get very nice results in editorial data. The other thing is that you should look at like the disambiguities, how you handle them. Do you want to have the rules of like, well, if I have Washington, it always means a location, but well, I mean, it's in reality it's not. So you should also look at how much ambiguity you have in your domain, and yeah, what is the final application? It's really important not to like. As a researcher, coming from university, I learned it when I joined the company that, no, I mean, you have to look first at the application, then build a solution for it. The second thing is that, yes?
Yeah, sorry, short question. What's the shortest amount it takes to analyze,
As to predict or to build a model?
You want to do sentiment analysis of reviews or something. And some reviews may be just, one sentence.
Okay, then depends on what you expect from that. Is it you want to do a document level analysis, or is it like entity level? Because when it's like multiple number of sentences, then you want to have an aggregated, which is a very big challenge of how to aggregate them. And I haven't seen in the state of the art a unique answer for that. And but usually it's like as long as you have one full sentence, we consider it as like, well, if it's a one full sentence, then we can consider it as a meaningful, at least in our industry, we can consider it as a meaningful part to analyze it. So the second thing is that data speaks. Well, you should look at your data domain, if it's a social or editorial, if it's inflected or not, or how is the data distribution in your training data. If you collect you want to categorize name entities of, I don't know, product and all the 5 categories that I said, and your data, the training data, 70% of it is about person, and the rest is about the other categories, you make a biased model. So when you collect your data, make sure that you have a good coverage of different categories. Okay, the second thing is about also, the third thing is actually about also, yeah, I partially talked about it, how big is your training data, how big is your test data. Some people come very selective, select only 100 sentence, and then they evaluate their model on it, and it happens to perform very good. But you should have a good representation of your training data to claim this is our performance and accuracy. And then, yeah, I mean, consider that there is a noise in data, and you have to do a pre-processing first, and then users' expectation and experience matters a lot. Okay, so getting back, yes, there are solutions, you can use them, but be very careful how you use them. There are some suggestions for reading. I shared the slides. You can look at them to get some insights of like a lot of these discussions that we had about the challenges. Okay, so if you're interested more, you can actually reach out to me, Bhaskar, and Ramin. Yes, But Bhaskar is more involved in the data enrichment, as we talked, in NLP, and Ramin is more involved in, actually he's the tech lead of the front end part of the story, the framework that we work on it. So if you're interested, you can, in the mingling, approach to us and we can discuss. And we also are looking for people who are interested to join us. So yeah, feel free to talk to Bhaskar and Ramin about it. Okay, demo time. Yes? Questions? No? Okay. Let's see if the demo works. So this is, actually I start from here. This is our demo environment, the framework, the in-house framework that we have before getting to the applications that the customers are using. So you see things that they are not still in the product yet, but they will be soon. One of the things that actually I think, I don't remember who asked, but someone here asked, was about, yeah, you asked, I remember, about if we customize our search. So one of the most important things is that sometimes users, they can't specify their intention behind. And then let's say someone is looking for Meltwater, but doesn't say that I actually look for Meltwater as a company. Meltwater can also mean melted water, and a lot about like greenhouse, or I don't know, like Iceland, global warming, and so. And to assist them to filter this, we have an advanced search, which is refining the query of the user based on the feedback of the user. So I go through them. Here, I think, well, this one is not relevant. Less like this. Less like this. Okay. Yeah, more like this. It's about the company. And one more about the company.
Good question.
Yes.
When you present a list like this, do you put weight on the source? For example, if a movie studio wants to see the reviews on Twitter for the trailer they put up, like do the users with more follow, more people following them have priority and stuff like that? Or for like, I don't know, review from The Independent has a bigger value than some random newspaper?
This is this is a specific use case that I'm talking about, the advanced search. But in one of the applications, like for instance, when we are looking for influencers, we have this weight of like from which sources has come, how many similar documents are out there. But no, here we don't have this specific thing. It's more about like how you weight things around enrichments. And yes.
I have a question. All these results are in English.
I set it to be only in English, but you can actually, I was afraid of breaking anything in before the search, but here you can basically select all sources or Sweden or like English, and Sweden is the default for me because I'm in Sweden.
But
yes.
It's basically like doing two searches with different dictionaries, or basically, I mean.
Well, we have in our database crawlers from like many different languages. And we index all of them. And so what happens is that if I set the filtering to have only English, then it looks at the enrichments and all the document sets that are only in English. So there is no really specific dictionary. But when it comes to specific enrichments, like in offline, when we build those enrichments, if it's like name entity recognition for Swedish, yes, we adjust the features according to the language, including the gazetteers. Gazetteers are Swedish gazetteers, but also English gazetteers, because you see mentions of not only Swedish but also English in Swedish news articles. Yes.
How do you deal with fair use and if I set my website to blocking all crawlers and search engines and everything, do you respect that? Or do you get the data anyway? Do you crawl my website even though I've used official standard?
I think you know, there are certain lines that crawling systems, if you want to be a legitimate company, you should, according to the law, you should not break it. I'm not in the content service team, so I can't answer how exactly what is the process that they have for the crawling. Many of them are outsourced, so that it's not like we have all the crawlings in-house. We get some of them from the third parties. And for some companies or like some publishers, we even have agreements with the publishers to get data from them. So it's like a wide range of content service, and yeah, I hope that my content service colleagues, they don't get upset about what I'm saying, because I don't have enough knowledge about their criteria. Yeah.
Two-part question, kind of related. Do you save for the next time they search? Do you save what they liked and didn't like in their filter? And if you do or don't, what if they misclicked more like this?
Okay. So the thing is that, again, as I said, this hasn't gotten to the product yet. So you see a very fresh, out of like almost ready to launch thing. But for this specific search where we get users' feedback, yes, we save what they have sent. They can say, reset it, I don't want it, continue from what I've refined, or they can actually, like here, I can say that, oh, I didn't mean more like this, I meant more, so you can change it. Yeah.
I also want to jump in one
yes.
of the answers. The main idea here is that every user who are using this is paying a lot of money, right? And when we are exposing a feature, we are very clear to them that if you want to use this specific feature, we are going to save all your data. And they are quite happy. And because you see that we have this reset button, so they can also, so they can also basically delete whenever they want to delete their history. So it's not actually a generic free things. So it's like customized for one particular user who is like, that user has a specific intent and want to get this kind of searches.
So usually, you know, what it happens is that a salesperson has to talk quite a lot with the customer to find out what is their intention and customize the search for them. This tries to help both a salesperson and also a customer to elaborate on their intention of the search that they have. So where were we?
You were going to find one more.
About Meltwater. What you know, you stand the software company. Yes, this is more like this. I already marked it. One more about Meltwater. It melted. No. Green glacier. Wow, just like this. No, this is about a lake. I already read it. Yeah, here. Because yeah, we have a business is cool in South Africa. Okay, so and here I can select if it's like a broad search or a sensitive search. Means that I, like as a user, I want to cover everything. It's okay if you find some irrelevant ones. And sensitive, it says that no, I don't want to have any irrelevant one. I want, even if it's a small subset, I want all of them to be relevant. I go for the broad and apply rating. We have only 2 positives and 3 negatives. It's a very small set. Still, we may not be able to cover all the intention of the user, right? And let's see if the network helps me here, please. I hope that I didn't actually press cancel. Let's see. Yeah. Okay. This is the refinement. Actually, one of the features is also like name entities. So here we say, okay, your intention was Meltwater, but also we want to have enrichment, like key phrases South Africa and market in the concept of meltwater or bazaar. And we don't want to have the concept Iceland. So this does, okay, no, sorry. This does actually do some set of refinements to our search. And you can continue this process. And here, one of the most important features is actually name entity recognition. So, another example. Here we have a search around meltwater without any filtering, so you'll see a lot of glacier and these kind of things. And what we do is actually we present a widget where the user gets the word cloud of the most common key phrases about that occur in the list of documents about meltwater in the search result. So this is one kind of insights that I was talking about, that is an accumulated insights for the customer. Okay. Yeah, this was here. Let's see if it gets back. Okay. Another thing that I was talking about was the entity sentiment. That here you see we are talking about meltwater again, and these are the top entities around them in the documents: Greenland, University of California, United States, meltwater, China, Earth, Perfect Point, Blind Arc, and Mint, newspaper, and CEO, PPC. And then here you see the green one says that, like, out of the mentions, collected mentions, 28, there were 28 and all of them were neutral. This is saying like 12 of them there were positives, and some of them, 8 of them, they were like neutral. Another thing that you see, like a lot of enrichments that we have here, and like basically these are from name entity recognition, and this is about Tesla, and we are looking for correlated enrichments around that in the search results within a certain period. And if they are highly correlated, then they are connected. And yeah, I mean, let's say we go here, and yeah, we have here San Francisco, magnetism, vision, Georgia University, drag physics, and so on. And then you can see this is like a person that is like information extraction is related to also Elon Musk. And another one is like how prominent an entity is a conversation, is in the conversation around the topic. And here you can see an example for Tesla that you like. These are the prominence entities in the search results. So considering that we have the name entity recognition, we can provide a lot of insights to the user to find out what's going on out there, just like, you know, besides looking at the search results. Okay, so I think I managed to finish the demo. And let's get to more questions if there is any. Yes. Yeah. I actually, oh, we can pass this.
All right, thanks for a great presentation. I was wondering, have you seen this thing about recurrent neural networks?
Yeah.
And in the case that they used it to replay the works of Shakespeare, they trained it with many iterations, and then they got it to eventually write the works, although it was actually not the real works, but it looked like it. Is this related to the NLP kind of stuff that you do, or is this a separate subfield that's springing up?
Okay, so one thing that I can say is actually a very good question. I think this is the next thing. Well, I mean, deep learning and recurrent neural networks, they have touched different things in text domain and image domain. And I think in terms of name entity recognition, I think this will be one of the next things to address, but it has been used already quite a lot in NLP. For example, in concept extraction, even if in query refinement or in categorization, I know that there have been works about using word embedding and topic modeling, and these are all applications of recurrent neural networks. So yes, it has reached to NLP too.
Thanks.
There was first someone here.
Yes, one question about abbreviations. In the Swedish language, we used to have dots
Yes.
in the abbreviation, but a few years back, I don't know how many, I'm 50 years old now, so I started using with the dots. Nowadays, people don't do that. You skip the dots. How sensitive is your processing for that, and are you sort of keeping up with the changes in languages so that it's always fresh, that it can adapt to changes in that country, that culture, stuff?
So actually, it's a very good question, and it's very challenging. The thing is that we try to use features that, if something happened in the past, and they are now part of the language or the history of the language, evolution of the language, we try to consider them. For instance, we have some definitions for prefixes as a feature, and we consider it. But one of the things that now we try to do is also how often we have to update our models. And when we update our models, which parts we have to update. And this is something that's is actually a ongoing topic, both in the state of the art and also in our research team.
So it's doable, because where you said about Einstein, you're looking for dots, the tokens. But if you remove the dots, what are the tokens? So it changes the rules.
The thing is that, for instance, when you extract the text from a news article, or just copy paste, or if you extract things from Wikipedia, sometimes you get a lot of broken sentences, and those causes a lot of noise. That's why one part of my presentation I said you have to be careful also about the noise in the data, and it's not easy to find a generalized approach. Sometimes you can find set of rules for detecting a sentence. Sometimes it's not that easy, and if you have a model that doesn't cover it, or if the cost of creating such a thing is expensive in terms of data collection and the time of development, then we try to do a data filtering to make sure that we have a data that actually represents the actual data, which doesn't have this kind of grammatical problem. Yeah. But when it comes to social, actually there is no such a things, right? So there we are more we use a different kind of part of speech tagging, and which doesn't look at the capitalizations, for instance. And then another thing is that for sentence splitting, for instance, very often 3 dots still means end of a sentence in social data, while this doesn't happen in editorial. So these kind of things, we adapt them considering the domain. Yes.
But are you using social data in production now, or is it more in a
we do
development phase?
No, we do use social data. Yes, there. Okay.
For you as a researcher and together with Meltwater, where do you see NLP and this sort of data mining to be going in the next 10 years? What are the coolest technologies to be focusing on?
Oh my God, this is really difficult question to forecast what happens in 10 years. I showed you this picture of how things have changed from emails to books to now Twitter data. So I can't really forecast for 10 years.
What about in your periphery? What are the most exciting fields?
I think, social data is really, in our industry, it's also important that you have a wide coverage over different languages. But one thing that is becoming a trend in the users is looking at the social data and try extract information from them. So that I think can be like a important focus. And then the other thing is that you should make sure that the system that you have can tolerate large volume of data and has a good performance. That's another thing. We have done a lot of restructuring to make sure that we maintain this. And I think that would be a challenge for standard companies to deal with at the moment. The other thing is that I think there are some certain things that they are mature enough in NLP. So what I can see would be interesting is actually building more complex insights from them, like creating extracting information retrieval, or like extracting relations between the entities and this kind of things, or analyze things over several documents, find the relation between different type of enrichments. So more complex things. And well, there are many of them already around, but many of them are just a claim. It's a kind of like a proof of concept, I would say. They are not really accurate ones. So it would be nice to see, especially like with deep learning, what people do to build more accurate things and less expensive.
Yeah, hi. So how close are we to do this in real time? Let's say you have like an ongoing chat. Could you do that for like every chat message in real time? And I know it's a question
about. Depends on what you are doing. I mean, for instance, we have a widget that's to extract sentiments from emojis in Twitter. Actually, I can probably show it right here. It's a prototype. Dashboard. Meetup.
I think in 1,000 years, when they find the remnants of our civilization, they're going to pinpoint where it went wrong.
The widget. Yes.
Emoji graph.
Yeah, I meant emoji graph. It's just the mentions of the emojis. Yeah. Okay. We don't have the other one in the dashboard yet. Okay. No, I don't have the social search. Okay, probably we can leave it for later because I have to go to the social channel first and create a new widget, so I skip that. Probably Robert will appreciate it. But yes, I mean, we have those kind of analysis, and then like if you have a crawler or an API that can give you online data, that's easy. I mean, there are APIs that they actually do kind of real-time, giving you statistics about hashtag mentions and this kind of things, or event detection. But one problem is that they are addressing one specific things, and it's just like collecting. It's not as simple as collecting statistics, but it's more about collecting statistics. But what we also need here for some of the widgets is that we also need to make those enrichments. So meaning that as soon as all the documents are crawled, we have to create those enrichments and then index them in our search, so that the user can be able to get those in their search results. So that's one challenge, to make sure that they are indexed. But for some widgets, like the one that I wanted to show, yeah, if you use just the statistics, then it's pretty straightforward.
I also would like to double check, like what you were saying is, let's say that we have an NER model, and yeah. So I mean, I don't know that if you are asking this question, that let's say if you have an NER model and you just feed the chat stream there, how fast it can.
Oh,
yeah.
Okay, this is a different. Sorry, I understood.
No, I think what you are saying is okay, but I mean, so if you are asking this question, so what we do basically, like when we develop such a model, we usually perform, this load test. So where we feed a huge amount of corpus,
and we check we basically plot that if there is any memory leakage or what is the time. So we run this algorithm for 5 continuous days, and then we basically have this plot. And it's quite interesting. But there we see that our NER model is quite fast. It's like it can detect, I think, 10 named entities in a second, for example. And also it depends, because when you build this kind of model, it's usually growing exponentially depending on your input data. Yeah. So basically you will have like for these 76K tweets, you may end up with having like 5 GB of data. So there, the challenge is that if you manage to redesign your architecture and then you load the model one time, then basically it can become quite fast. So it's all depends on how your software engineering techniques are. Otherwise, you may end up in like having 5 seconds and detecting one. So it depends a bit of that engineering as well.
Yeah. So if you give a new document, like not going to the whole API, like the application, but directly to name entity recognition. Yeah, Bashar explained it quite well. It's quite fast because you have already your model and everything in place.
Should do one more. Is that good?
How important are software that is open source to what you're doing at Meltwater, and are you providing any kind of giving back to the community? Any do you open source any of your tools?
Okay, it's a very good question. One thing is that at the end of the day, the application that Meltwater is creating, it's commercialized. So that like a customer buys the application and creates a specific agents and use it for their work. So in this sense, we are like a commercial company, and we make sure that if we use a component, we'll check the license and making sure that if it's something that we have to release or not. But on the other hand, when it comes to sharing the knowledge and experience, we are quite open, like this one. I mean, I talked about things that haven't been released yet, or things that we are publishing as like in paper conferences. And we try to communicate and learn from others and exchange. And then we also have this non-profitable organization in MEST, as a business school, a kind of incubator in Africa, so where they try to pay the debts back. So that's what I know. I don't know how much it answers your question and concern.
Well, thank you very much, Sahar. That was great.
And just one thing, I mean, thanks for listening. And as I said, I mean, we love the discussions and challenges. So just after the talk, approach to us, and we can have friendly, nice chats.